All right. So 3-6, applications of sequences and series. You guys are going to be able to apply the concepts of arithmetic and geometric sequences and series to real world problems. You can use these, like I said, to apply them to everyday life. And we're just going to jump right on into it with example 1, which says a woman deposits $100 into her son's savings account on his first birthday. On his second birthday, she deposits $125, $150 on his third birthday, and so on and so forth. Looking at this example, does this model an arithmetic or a geometric sequence? Woman goes in, $100 first birthday, $125 second birthday, $150 third birthday.
Arithmetic?
It's arithmetic, okay? Because she's depositing how much more the next birthday? 25. So that 25 would represent what of an arithmetic sequence? It'll represent the D. Now remember, with arithmetic, D goes with the arithmetic sequences, the common difference, and R goes with geometric, okay? So this is arithmetic, okay? Common difference is $25 more that she's adding. Now, the first question asks us, how much money would she deposit on her son into her son's account on his 17th birthday? What does 17 represent? The N, okay? And considering that this is an arithmetic sequence, and it's asking us how much she's going to deposit on a specific birthday, are we going to use the A sub n formula, or are we going to use the S sub n formula? A sub n, because we're looking for a specific year. Is everyone following along, seeing what's happening? We're reading the problem, we're deciding if it's arithmetic or geometric, and then figuring out which formula we're going to use. Now, we know that 17 is N, D is 25. What is A sub 1? 100. How much she deposits on his very first birthday. So, I'll plug everything in. That's A sub 17 equals 100 plus 17 minus 1 times 25. And we type that into our calculator to get our answer. Compare with our neighbor, our answer. Shalyn, how much? $500. $500? Did you guys get that? Very good. Now, that's not how much is going to be in his account by age 17, but that's just how much she's going to deposit on that particular year. Now, part B says how much in total would she have deposited after her son's 17th birthday? Total. Total means what? In all. I'm going to what? Add it all together, which means I need to use the S sub n formula, yes? S sub n, N over 2, A sub 1 plus A sub n. Do I have all my pieces to use this formula? What's N? 17, because we're trying to figure out how much after his 17th birthday. What's A sub 1? 100. And then A sub n is basically asking us for how much he got on his 17th birthday, which was what? 500. So we're going to add 100 to 500 and then divide it by whatever 17 over 2 is. Or not divide, I'm sorry, multiply it by whatever 17 over 2 is. How much does this son have in his account? $5,100 in his account. Okay? And there you go. Apply it to the real world. That'd be nice, right? If your parents sat there from the day you were born, decided to invest all this money in there for you so you can have a nice little chunk of change going off to college after high school. Yeah, people are broke nowadays, okay? It's not really the truism of life. All right? But there you go. Questions? All right. Let's look at the next one. It says a ball is dropped vertically. It reaches a height of 2 meters on the first bounce, and the height of each subsequent bounce is 90% of the previous bounce. First off, what does subsequent mean? Afterwards. Okay, so the first bounce was 2, and every bounce afterwards was 2%. 2%? Ooh, I meant 90% of the previous bounce. Does this model arithmetic or geometric? This one's very much geometric because you're doing 90% of the previous height. So, what's our R? 9 over 10. Or 90%. 90%. Are we going to plug in 90 for R? Or are we going to plug in something different for R? Be 0.90. Okay? Be 0.90. Because when you're working with percentages in math, it's always the decimal form of the number. All right? So this is geometric. Our common ratio is 0.90. And now the first question asks us, what height does it reach on the 8th bounce? For this one, are we going to use A sub n or are we going to use S sub n? We're going to use A sub n because we're looking specifically for the 8th bounce. What's A sub 1? 2. 2 meters. It's A sub 1. R. 0.90. And then 8 minus 1. What's 8 minus 1? So essentially this is 0.90 to the 7th power. Now before anybody asks, how are we going to round this? 3 significant figures. 3 significant figures. This is a decimal that keeps going, right? Does everybody see that number in their calculator? Is everyone doing it? Okay. Is everyone doing it? You're typing this in. You're trying to figure out what is this? What is that answer? All right, so what did we get rounded to 3 significant figures? 0.957. Yes. Remember, with 3 significant figures, you start with the first non-zero number, which would be the 9. That's the first. That's the second. That's the third. So the 5 would cause you to round that 6 up. So it's 0.957 meters. Questions? Now, what is the total vertical distance traveled by the ball between the first and the 6th time the ball bounced? Or the ball hits the ground. How do I figure that out? The other one, the S sub n one. Okay? What's going to be n?
6.
It's going to be 6 because it's asking for the 6th time it hits the ground. So 6. What's my first term? 2. 1 minus, what's R? 0.90. Raised to the n. All over 1 minus R, which is 0.90. So we need to figure out what this is. As tempting as it may be, do your best not to round until the very final end. So my suggestion to you is maybe you should go ahead and do 1 minus 0.90. What's 1 minus 0.90? 0.1, okay? Hopefully everybody knew that. In case you didn't, figure out what the denominator is. So that way when you do all of this jazz up here in the numerator, you just have to divide by 0.10, okay? So everyone now should be finding the sum of the first 6 bounces. All right, let's see how we do. So you had to start by raising 0.9d to the 6th power. So then that gave you a decimal of 0.3531441, and it probably kept going after that. Okay? Then you had to subtract 1 from it. Now, what you really could do, you could just do -1 and then just change the sign, because that is essentially what you're going to end up getting. So then you get another long decimal multiplied by 2. So then you'll have 0.937118 and some change divided by 0.10. And so you'll end up with 9.3 what? 7 meters. And that is the total distance.
We will stop the secure school. We are safe.
All right, looking at number 3. It says 2 students, Ann and Ben, they're playing Monopoly. Okay? Each time Ann passes go, she receives $15. Each time Ben passes go, he receives 8% of the amount he already has. Both students start with $100. Now, raise your hand if you've ever played Monopoly before. We are taking out the whole idea of landing on community chests, taxes, landing on someone else's property to pay rent. We're taking all of those things out. Right now, they're just rolling and going around the board. That's what they're doing, okay? So take out all these other situations, all these other scenarios. Sure, yeah, like Candyland. Okay? So, how much money will Ann have after she passes go 10 times? And she's receiving $15 every time she passes go. Huh? It is arithmetic, okay? We can actually use the arithmetic sequence formula to figure this out. Now, in your mind, you might be figuring out another maybe easier way to do this. And yes, there is another easier way to do this, okay? But because we're doing sequences of series, I'm going to harp on sequences of series. Yes? Okay. What's n going to be? 10. So this is going to be a sub 10. But now my question to you is, what's my first term? She starts with $100. When she goes around the first time, it's 115. If we make n 10, we have to take into consideration that this 100 is not the first term. That's how much money they're already starting with. Okay, so when she goes around for the first time and passes go, you could do that.
You have to have how much money will you have, and all after that's good time. So it would be all of that. Right?
But see, if we make our first term the 115 number instead of the 100 number, it will take care of all of that to begin with. Okay? So, yes is what they start with, but Ann's first term is going to be $115. Does everybody understand that? So we'll have 115 as our first term, plus n minus 1 times d, which is 15. We'll type that into our calculator. We'll get our answer. Still recording. How much? 250. Ben, what about him? He's geometric, okay? Ann was arithmetic. Ben was geometric. And if I make N 10, what is Ben's first term? Huh? Not 180. Say it again. A little louder. 108. Okay? Because he's receiving 8% of the amount he already has. You can figure this out by doing 100 times 0.08 and getting $8. And then adding that. Does anybody know the shortcut? How to get straight to 108? Does anybody know that shortcut? Yes? If you multiply by 1.08, it takes me straight to that number without having to add that extra 100. Okay? So Ben's first term is 108. We plug it into our formula to figure out how much he has after he passes go 10 times. Okay? So we'll plug it into the formula. 108. What am I going to use for my rate? It's going to be 0.08 or 1.08. It's going to be 1. Without it, you're going to have to figure out how you're going to take into account that they're doing 8% of the amount. Okay? I'm not even quite sure how you do that just myself. So go ahead and type this in. And we are talking about money, so I'm going to ask you to round to 2 decimal places because we are talking about money. Two decimal places. What is it? $215.89. And for simplicity's sake and time's sake, change this down here to 10th. Okay? For simplicity's sake and time's sake, change that number down there to the 10th. Who will have the most money in their account after the 10th time Ann and Ben both pass go? Ann, clearly. It won't always be Ann. Okay? We'll save that for your upper level classes to show you how to figure it out. You know, how many times they would need to pass go in order for Ben's amount to exceed Ann's amount. I'll leave that for your pre-cals and your IBs. Yes? Yes. How is this so far? It's all right? Okay. Well, I want you guys to do this one on your own. Okay? Then I'm going to have you guys compare answers. All right? So I want you to do example 4 on your own. I wanted to make sure that you guys had, an appreciation for us teachers. Okay? Because that's not including taxes or medical bills or anything like that. That actually does get taken out of, our checks. Okay? And you know good and well that's not Florida, where first year teachers coming in making $45,000. Okay? In Polk County, they're making $40,000. All right? And it definitely ain't increasing like that per year. It may increase $150 a year. Okay? So have a little empathy for your teachers. Okay? Here we go. All right. What does 45,000 represent? The A1. And the 1750 number represents common difference, which means that this is an example of what type? Arithmetic. So if I'm looking for the 5th year of her employment, that is going to be S sub 5 or A sub 5? A sub 5. And I plug everything in. My first term plus N minus 1 times D. So yes, that does turn to 4. I multiply 4 by 1750, and then I add 45,000. And in her 5th year, she's making how much? 52,000. This is not an accurate representation of teachers in Florida. A 5th-year teacher is probably making around 46,000. Sorry, Polk County teacher is making around 46,000. She remains in this employment for 10 years. That's when she got smart. And she says, I can make a little bit more money in another state. Yes. Okay. So calculate the total salary she earns in this employment during these 10 years. A sub n or S sub n? And what's n? 10. So that's going to be what? 10 over 2. 45,000. Ooh. Do you know A sub n? You gotta find it. Because the formula says A sub n, which would be A sub 10. In the previous problem, we found A sub 5, so we have to find A sub 10 using the same formula, the same setup. This time just using 10 instead of 5. And you said it's 750. And some of you might have been thinking, well, can I just double it? No, not quite. So once I plug all this in into my calculator, what's the sum? 28,750 dollars that we do not get to keep. If we're lucky, over 10 years, we might be able to save 8,000. Maybe. That's if we don't get any car accidents, no health issues. We haven't had to move from apartment to apartment because the rent done gone up. Or if we live in a house, mortgage hasn't gone up. Okay? This is not an accurate depiction of the teachers that you guys have on a daily basis. Okay? Just letting y'all know. All right. Here we go. Number 5. I'm going to do this one with you guys just to make sure you guys kind of understand the process because this one's a tad bit different. The annual fees paid to a school for the school years 2001, 2000, and 2002, that's a mistype, increased at a geometric progression. The table below shows this fee structure. Okay, so the fees in 2000 was $8,000, 2001 was $8,320, and 2002 was, as you can see. Calculate the common ratio for the increasing sequence of fees. How do we find the common ratio? Second by the first. Now, it's interesting that you guys say that. You said divide the second term by the first. What's the second term? 8,020. Okay. So you're saying that this is our second term. So then this will have to be our first. This will have to be our third. Okay. There is a reason why I asked, because it's going to play a part in B and in C. Okay? When I divide that, what do we get? 1.04. That represents our common ratio. That takes into account that whatever the percentage of increase was for the fees, they've already added it to the 8,000 that it already originally was. That's what that 1 represents. Okay? So the increase was actually a 4% increase in fees. Does everybody understand? Based off that number? Okay. The fee continued to increase at the same ratio. Find the fees paid in 2006. 2006 is what term? Very good. It is the 7th. It is not the 6th if you're considering 8,000 to be the first term. Okay? So this is 7, which means you need to do A sub 7 to find our answer. Okay? Go ahead and do that now. And while you're at it, go ahead and find C as well. So When you plug in 7 for n, again, we're using 7 because we made 2000 our first term. So that means that 2006 is going to be our 7th term. We're plugging in 8,000 for our first, 1.04 for our ratio, and then 7 minus 1. What were the fees paid in 2006? Rounded to 2 decimal places. $10,122.55. Yes. Here, a student attends the school for 8 years starting in 2000. Find the total fees paid for these 8 years. N is going to be what? 8. N is going to be 8. And because I'm looking for the total fees, I'm using the what? The sum formula. So I'm finding the sum of the 8 years. Okay? Starting with my first year of 8,000. 1 minus my ratio to the 8th power all over 1 minus my ratio. It should be a large number because I'm adding $8,000, 8320, 865280. I'm adding up a lot of terms. What is my sum? I heard $73,713.81. Questions on this? The ones that involve years does kind of affect how you look at N, okay? So be very cautious on those. But whatever you decide, you got to stay consistent throughout the problem, all right? Look at number 6. Number 6 is similar. We're talking about a population of big cats. And it's increasing at a rate of 5% per year. Increasing at a rate of 5%. Arithmetic or geometric? Geometric. At the beginning of 2004, the population was 10,000. I want you guys to I want to see if you guys can do this before I jump in. I want to see if you guys can do this before I jump in. So I want you to do A, B, and C. So the population of big cats in Africa is increasing at a rate of 5% per year. If it's increasing at a rate, then you already know that this is geometric, and your common ratio is what? 1.05. At the beginning of 2004, the population was 10,000. 2004, it was 10,000 big cats, which means that you can treat 2004 as your what? As your 1, your first term, okay? And if you do that, you just have to be careful when you're trying to figure out the population of big cats in 2005 and 2010. 2005 would represent what term? A sub 2. 2010 would represent A sub 7. Because if 2004 is your first term, 2005 is your second, 2006 is your third, 2007 is your fourth, 2008 is your fifth, 2009 is your sixth, and then 2010 is your seventh. Okay? Then you just use your formulas. First term, ratio, n minus 1. First term, ratio, n minus 1. Now we're talking about cats. No decimals. You can't have a fraction of a cat, okay? So you can round to the nearest whole number, making sure you round correctly which way, or you can always round to 3 significant figures. I will not fault you if you round to 3 significant figures. How many cats in 2005? 10,500. In 2010, how many cats? 14,400 cats. Now, I know this one had a decimal after it, but surprisingly, that is 3 significant figures, okay? 1 1, 3, 4, those are your three significant figures. You put zeros for the placeholders. Okay? Put zeros for the placeholders. Now you have to find the number of years from the beginning of 2004 it will take for the population of big cats to exceed 50,000. Number of years sounds like what? It sounds like N. Number of years, number of terms. A sub N. You had to use A sub N for this one, not sum. You had to use A sub N. So, if I'm using this formula, what's going to be A sub N? 50,000. Because I'm trying to figure out what year it exceeded that amount. My first is still 10,000. I'm looking for N. Oops. What did I do? I used arithmetic. My mistake. A quick fix. Ratio. N minus 1. I'm looking for N, just like I was looking for N in my do now, and just like we spent all Friday doing. I have to solve for N. How do I start? Divide by 10,000. What's 50,000 divided by 10,000? 5. Now what do? The log of our answer divided by the log of our base. All of that equals N minus 1. When I type in and I get a decimal that I am not going to round. I round after I do my final step. What's my final step? Add 1. So I'm going to type plus 1, enter into my calculator after I figure out what that decimal is, and then I round that. And considering that I'm talking about the number of years, how should I round? Like, I'm rounding after the decimal point? I'm not considering my decimals. I've got to talk about years here. So I need whole years. Okay? What is the decimal that you get? I get 33.9 and some change, right? So is that going to be 33 years from 2004? Or is that going to be 34 years from 2004? 34 years later. The population is going to exceed 50,000 big cats. So when you're looking at applications, you have to figure out, first off, is it arithmetic or is it geometric? From there, you have to figure out which formula are you looking for. If it's not talking about total, if it doesn't give you the total, or it doesn't say sum or altogether or any other words that mean total, you're not using the sum formula. You're using A sub n. Okay? And then it's a matter of what part of A sub n are you looking for. Okay? So are there any questions on applications?